Download this code from codegive.com, link in the description below. From Zero to Async in Embedded Rust. Asynchronous programming in embedded Rust can be both powerful and complex. This tutorial will guide you through the process of setting up an asynchronous environment for embedded systems using Rust, from the basics to a practical example. Prerequisites. Before we begin, you should have 1. Rust installed. Make sure you have Rust installed on your machine. You can install it from rustup.rs, https://rustup.rs. 2. Embedded target. You should have a specific embedded target in mind, example thumb7m non-EB for ARM cortex-m. 3. Cargo. Familiarity with Cargo, Rust's package manager and build system. Setting up the environment. 1. Create a new project. Bash. Cargo new embedded_async_example bin. cd embedded_async_example. 2. Add dependencies. Open cargo.toml and add the dependencies necessary for embedded async programming. We will use embedded-hal, async-std, and Tokio for our async runtime. toml. Dependencies. Embedded-hal equals 0.2. Tokio equals version equals 1, features equals full. 3. Target configuration. Set up your target. You may need to create a .cargo/config.toml file to specify the target architecture if you are using a specific embedded platform. toml. Build. Target equals thumb7m non-EB. Writing async code. Basic concepts. Futures, an abstraction that represents a value that may not be available yet. In async Rust, functions that return a future will yield control when they cannot proceed. Async functions, functions defined with the async-fn keyword. These functions return a future. Example, blinking an LED asynchronously. In this example, we will create a simple asynchronous program that blinks an LED. We will simulate a simple embedded system without specific hardware, so we'll use a mock and some delays. 1. Define the async blink function. Create a new file named src/main.rs and start coding. Rust //src/main.rs. Use Tokio time:sleep, duration. Async-fn blink_led. Loop. / simulate turning the LED on. Println, LED on. / sleep for 1 second. Sleep, duration from _secs, 1, await. / simulate turning the LED off. Println, LED off. / sleep for 1 second. Sleep, duration from _secs, 1, await. Tokio main. Async-fn main. Blink_led, await. Explanation. Blink_led function. This async function simulates the LED being turned on and off with a delay in between. The sleep function is used to create the delay asynchronously. Tokio main. This macro sets up the async runtime for our application. 2. Running the example. To run the example on your embedded hardware, you might need to cross-compile the code. Bash. Cargo build target equals thumb7m non-EB. Flash the compiled binary to your embedded device using tools like Cargo Embed, OpenOCT, or ProbeRs. Using embedded-hal. If you want to interact with hardware like GPIO for blinking an LED, you can use embedded-hal. Here is a more concrete example. Rust. No_std. No_main. Use cortex_m_rt entry. Use embedded_hal digital v2 output pin. Use panic_halt as underscore. Use stm32f4xx_hal delay boext, POC, prelude asterisk. Use Tokio time sleep, duration. Async fn blink _led p, output pin, mut pin, p. Loop. Pin.set_high, .unwrap. Sleep, duration from _secs, 1, await. Pin.set_low, .unwrap. Sleep, duration from _secs, 1, await. Entry. Fn main, dash. Let cp equals cortex_m peripherals take, .unwrap. Let dp equals POC peripherals take, .unwrap. Let rcc equals dp.rcc.constrain. Let clocks equals rcc.cfgr.freeze. Let bo equals dp.bo.split. Let mut equals bo.pa5.into_push_pull_output. / run the async blink function. Tokio runtime builder new multi_thread. Worker_threads, 1. Enable_all. Build. Unwrap. Block_on, blink_led. Loop. Explanation of the embedded example. Hardware-specific setup. The code initializes the microcontroller peripherals and configures GPIO for the LED. Async blink with hardware. The blink_led function controls the actual LED pin using the embedded-hal traits. Conclusion. You now have a basic understanding of how to write asynchronous code in embedded Rust. This tutorial covered the setup, basic async programming concepts, and a practical example of blinking an LED. As you delve deeper, you'll find more complex use cases and optimizations for asynchronous programming in embedded systems. Further reading. Rust Async Book, https://rust-lang.github.io/async-book. Embedded Rust Book, https://docs.rust-embedded.org/book. Tokio documentation, https://tokio.rs. Happy coding!